Welcome to GW Integrative Medicine, the podcast about disease prevention and health promotion from the Office of Integrative Medicine and Health at the George Washington University School of Medicine and Health Sciences. I'm Dr. Lee Frayne, Director of the Integrative Medicine Programs and an Associate Professor in the Department of Clinical Research and Leadership here at GW.
And I'm Dr. Misha Kogan, Medical Director of the GW Center for Integrative Medicine and Associate Professor of Medicine at GW. Today on the pod, we're going to talk about the science behind nutrition, nutritional neuroscience with Stephen Fleming's PhD.
An expert on nutrition and cognitive development, Dr. Fleming is also the co-founder and CEO of Traverse Science, Inc., a company that helps researchers at global nutrition organizations take a visual and evidence-based approach to scientific substantiation. Welcome to GW Integrative Medicine, Stephen.
Hey, it's great to be here. Always nice to be called an expert, so very great. Looking forward to this.
Yeah, absolutely. So let's just get right into it. Let's get a little bit of background for our listeners here. What is nutritional neuroscience? And maybe, why are we even talking about it?
Yeah, I'm giving a little bit away because I got a little bit of a pre-read on the questions, but I thought about what textbook answer I should give to this, and I thought, it's just food and brain stuff. Anyone who is studying a lot of brain things and doing a little bit of food stuff, they're probably doing nutritional neuroscience, and on the other spectrum, you have, hardcore nutritionists who then dabble in some of the brain psychology stuff. They're all doing nutritional neuroscience, and I went to University of Illinois, Urbana-Champaign to get my PhD in neuroscience there. And there's all sorts of, ways people like to subdivide neuroscience. And some people are like, well, this is more behavioral psychology and that's more social psychology. And others who are like, nutrition is just biochemistry. So it's just food and brain stuff, measure. You could be doing magnetic resonance imaging, electroencephalography, questionnaires, behavioral tasks on the brain side. And I think if you're just doing anything remotely related to feeding a subject, human, animal, or otherwise, or different nutrients, you get to call yourself a little bit of a nutritional neuroscientist.
I love that. And we have the same problem with kind of nutrition broadly, as you alluded to, right? Nutrition is just biochemistry. Or are we talking more about, dietary intake and that side of nutrition? So I like that scope, and that it's really kind of the beauty is in the eye of the beholder.
Yeah, it's a little bit dangerous, because if you just say nutrition is biochemistry, you'll get a bunch of biologists who are like, well, I'm good at that, so I guess I know nutrition now. And, I did a lot of work in pigs and mice, and one thing you maybe don't want to do in all of your studies is, or you want to be intentional about, are we going to test them when they're fasted or when they're in a fed state? So if you're testing animals for their memory and they're hungry, they're releasing ghrelin. Ghrelin tends to, make them more anxious, but also a little bit more focused at the same time. And so, we might have just interdisciplinary discussions on protocols. We're like, okay, well, the nutrition people want to get blood samples and they need them to be fasted. And how are we going to, incorporate that into a schedule where we're supposed to be doing behavioral tasks? And you don't want, some of your subjects to be fasted and the others not. So there's definitely some subtlety in there.
Right. And this is why team science is kind of how we do science now, right? Because you can't be an expert in everything at these intersectional topics.
That's true. In fact, I would say if you call yourself an expert in nutritional science, which I do feel I am, I actually just feel kind of like a half-baked neuroscientist and a half-baked nutrition scientist. Because if you're going to put me head-to-head with either one of the purists, they're just going to totally dominate me in their ability to talk circles around it. But you kind of, on those teams, I think it's really important to have someone who can communicate between both of them and understands the limitations and opportunities between the two. I
completely agree. And I feel the same when we talk about immunology. Even though I have training in both immunology and nutrition, you put me up against the purists, you're right. They are so deep on the one topic that it's really hard to trump them. But yet, getting an immunologist and nutritionist to talk to each other is not easy.
No. I reluctant. I wouldn't call myself nutritional neuroscientist for a long time. And then after a while, I was like, no, I've been doing it. I think I've got it. I can lay claim to the title now.
There's such a big divide between the neuroscience and then science of disease reversal or disease prevention. in cognitive field, like let's say, we understand that nutrition plays a critical role in neuroscience, but we know actually quite little about, say, how to prevent or reverse certain medical problems. Just curious if, how you're gonna respond to that. It's not a question, as a statement.
No, I think what makes it so difficult is there's a big distance between the diet and the brain. In the fact that, you eat something, it goes through your mouth, stomach, intestine, large intestine. These things are not going to the brain immediately. Or maybe what I mean to say is a lot of the effects that nutrition has are really indirect because it takes absorption and metabolism and transport of whatever it is to affect the brain, or maybe honestly the brain's not even really being affected that much. Maybe other organs are. So the first study I took part of was about prebiotics and brain development, and I was like, what a waste of time. Isn't this just the stuff people take for a laxative? And I was pleasantly wrong about that. That was kind of at the beginning of when the gut-brain axis was becoming really huge. And it's kind of easy to take a really reductive approach of like, this thing is in the brain, and so maybe if we eat more of it, that would be a good thing to do. And, those who maybe don't understand the gastrointestinal physiology wouldn't realize that just because you ate it doesn't mean it's going to get all the way to your brain. I think a really common myth is that, the first part is not a myth. It's that I think something like 95% of the serotonin is produced in the gut by enterochromaffin cells, and a minority of the serotonin, if you were to measure it in your entire body, is actually in the brain. And so, some think, wow, look at all the serotonin that's in the gut and is going to the brain. Well, the brain's going to regulate its own serotonin. It's not necessarily that what's in the gut is getting into the brain. But there's all sorts of different bidirectional communication that occurs. So, just something can happen in the gut and have distant effects in the brain. Absolutely. But it's kind of easier to figure out, like, does eating this thing make someone smarter or healthy? It's just so much way harder to then explain why.
Mm-hmm. Yeah, I guess in animals it's really easy to do so, but then translating all of this to humans, that's a whole different conversation.
Well, I would say even in animals, it's like you get one step further. And so I'll pick fiber just because that's what I have the most experience with. Like a dietary fiber, which is not going to be digested in your small intestine by your mammalian enzyme. It's going to require your gut bugs to ferment that. And so there's research out there showing different types of fibers can, improve aspects of cognition or emotional well-being. And you can study those in animals, but it's like you're only getting one step further anyways. You're like, okay, well, we can measure what went on in the gut, and we see that XY bacteria went up or down, or that they fermented and produced these short chains, but now what are they doing? And it's always just like this one more question. There's like 100 steps in between them. With my background in animal science, obviously I think there's value to it, but translating it is incredibly difficult. And, to be honest, sometimes I'm like, maybe we should just do more human research to even figure out, like, is this reproducible, that having, X amount of fiber improves cognition, before we get enamored by the cool biology of it. Let's just fully replicate that this actually does have a beneficial effect before, spending a decade or several on what the mechanism might be.
Stephen, I've had kind of come to the same conclusion as someone who has a molecular background and has also worked extensively in cell culture and animals. I was certainly taught that's sort of where we start. We start with the lowest level of evidence, and then you move your way up the pyramid. But when we do that, I think the problem is that we often are spending a lot of effort, like you're saying, on things that turn out to even pan out in humans. Yes. Whereas if we do some of this relationship exploration in humans, at least we know then the mechanism we're exploring is relevant.
Oh, man, I agree 1,000%. I almost think a top-down approach needs to happen. And it makes sense what many of us have been taught, in the sense of, like, it's cheaper to do animal research, and it might be the more ethical choice if you don't know what's going to happen in humans, depending on the study you're doing in nutrition, though, I mean, it might be pretty clear if you're just asking them to eat more vegetables. That seems fairly ethical to me.
And probably a good idea for most people.
Yeah, exactly. And I was working on this project with another group and reviewing the science, and a lot of the science was just so like strong in the sense that like we looked at these knockout mouse animals, and when they eat this, you get these incredible this myelination in the brain, and they're better at all these behavioral tasks. And then you look at, okay, what about not genetic knockout models? And it's still pretty strong science, but it's like just a little bit less strong. And then we looked at the pig studies and the monk primate studies, and those were just like way less strong. And then we looked at the human, and it was even less. And so we were going in circles as a group on like, how does this thing work and what's the mechanism? And I kind of walked away from it like, there isn't a mechanism. There's nothing happening. It doesn't pan out to larger animals. It doesn't pan out to humans. Like we can stop with exploring how this works in mice because it doesn't seem to be working in humans.
I'm going to cut out this exact part, the last 60 seconds of it, and put it somewhere that I can send every response to that to every single daily email I get from patients who's saying, I found cure for my Alzheimer's disease. Here's the mice study showing that this food is effective. Then prescribe it to me tomorrow. So I'll email that and say, nope. Here's an explanation why you shouldn't be doing this. Yeah, that actually comes up every day in clinical practice.
I actually have a similar experience with a lot of my students too. I mean, in the integrative field, often it's because people get very excited about this cutting edge research, and the cutting edge research is often in animal models. But then what they're not considering is the fact that that doesn't mean this is going to happen in humans.
So, Stephen, practical question. To your mind, if you take 100 cool new dietary products or nutritional extracts, what percent do you think will end up in humans? Putting you on the spot.
Like actually working in humans?
Yeah.
Maybe like 10% or less, or 5%. So that's a really hard question to ask, and I'll tell a story of my experience. I went to a trade expo called Supply Side West, which has all these supplement groups in it. And at the beginning of my career and my more entrepreneurial career, I thought there must be like a lot of money in supplements for research, which there is not actually. Supplement companies do not do a lot of research. Some of them might take issue with me saying that, but if you compare the investment in research between like a food manufacturer and a supplement, I think it's night and day. And I was going around and I saw the most crazy claims on all of these like booths, and I just like picked up one of their brochures and it's saying how it can like reverse cellular aging or something like that, and I was like, whoa, that's crazy. Like I'd never heard that. I'm like giving the benefit of the doubt at this place. Like I really should have been more skeptical, but then I looked at the reference and they're talking about, you know, they fed this I forget what it is at this point, but they looked at it in C. elegans and would, you know, the nematode. And I would not denigrate studying that animal model at all. It's like beautiful and elegant, and you have a lot of control over it. But I was like, this doesn't fly. Like you can't be telling people to take this because it's going to slow down aging because of what you found in nematode research. Like really cool mechanistically, but there's a really uphill battle to go. And I think there's probably more evidence of this failure to translate in drug-related research, which I'm not really that qualified to talk on, but you know, you do hear about all these really promising drugs that seem to alleviate or eliminate symptoms of various diseases and disorders, and I'm like, where are they? How have we not cured these things, and they're just not translating?
They're in the valley of death.
Yeah.
Yeah, just like this new drug Adalimumab that just went into the valley of death. It's an Alzheimer's drug that was supposed to clear the plaque.
I mean, it's like, I don't think a lot of people like to admit this, or I shouldn't say admit it, but my perception over time has been it's actually a lot harder to change or influence brain development with nutrition. I mean, you can clearly, like, if someone is iron deficient, that has very clear, very measurable effects. You know, if you look at deficiency, yes, you can see pretty night and day effects. But once you get to a pretty healthy person to alter their diet and optimize them to make them even smarter or more resilient to stress. I think it's incredibly hard to do that through the diet. And, there's no shortage of social media saying that, if you're sad or depressed or struggling with whatever it is, that like you just got to work on your diet and sleep and exercise more. I believe all of those things are really good things to do, but I think it does kind of like give people this idea that they could fix real problems they have could be fixed by things that are not medicine, and they need to be using medicine, not necessarily food, which might allude to my opinion on food as medicine, but I'm kind of just...
It's only one piece of the puzzle, and I think that's sometimes it gets lost in the conversation about food as medicine, and we in the integrative space should not be forgetting that, because that's exactly what we do, right? It needs to be multimodal. You need to be hitting every aspect of a person to really be making an effect. And if they're not sleeping and you're giving them a drug, well, then the drug's probably not going to work very well. But the same is true of vice versa.
Yeah. And of course, it might be better maybe to evaluate if you need a certain therapy by getting to a healthier place first. I can only really speak from my own experience, which was finally at the age of 30 years old, getting diagnosed with ADHD, which I barely needed a diagnosis. I knew it was there the entire time. It's like everyone in my family has it. But my older brother had it, and I remember talking to him, asking him like, do you think me and your other brother have it? And he's like, 100%. And which encouraged me to go talk to a psychiatrist, and he's like, oh yeah, you've got severe ADHD. Once I was medicated, it was like a watershed moment. Like I should have been doing this my entire life. And what's very difficult with nutrition is and what I think is different from medicine and even something like exercise is it's really hard, I think. Some people claim they can tell a difference right away, but it's really hard to connect, I made this change in my lifestyle, specifically my diet, and now I have Y feelings. It just takes, chronic diet-related diseases take a really long time to develop, and I think on the reverse, if you make improvements in your diet, it might take a really long time to figure out what feels better, and we habituate to things so slowly that you might actually be better, but not feel any better.
Yeah, and the same is true of people who, switch their diets and they immediately feel better, but then in the long run, they no longer feel better. So it's just, the diet is so tricky, in part because you need to constantly be making sure you're getting enough of everything. And if you're picking something particularly like a restrictive diet, which are often quite popular these days, you're probably missing something. And it may not take 2 months, 6 months, but in a year later, you're probably going to start manifesting the fact that you aren't getting enough of, B12 or magnesium or something like that.
Yeah, that's really true. And the way you would assess some of these things on a research level is kind of, you mentioned there that habituation. You can see in some studies, if they do a lot of follow-ups, maybe the first month or so, there's a big difference, and it kind of levels out over time. And let's say you were measuring sleep or emotion. So those are two things that are really subjective and perception based. And so the European Food Safety Authority has these guidance documents out, mostly for industry in terms of if they want to make a health claim on one of their products and say eat this and you're going to sleep better, about what type of evidence you need to demonstrate that someone's sleep or maybe emotional well-being has improved. And those two are distinct from, say, measuring something like attention, because someone's attention can be measured objectively. You give someone a reaction test, and you can look at two things: how accurate are they, and their latency to make a decision on something. So how quickly can they make a decision, and is it correct? Those are objective measures. But to measure emotional well-being or something like sleep, let me start with sleep actually. You could look at time spent in bed or time in deep sleep or number of times they woke up. Those are objective measures, but they actually don't tell you if the quality of the sleep has improved. I'm not debating that they're probably correlated with it, but you need the subject's perception, a self report on a validated questionnaire in order to make a claim on food that sleep has improved. So someone might run a study and they're like, hey, people are sleeping more on this. But if the self-report of the quality of their sleep doesn't change, that objective measure of more time in bed or whatever doesn't actually matter. And so because you're looking at self-report, one question I have is in relation to like, okay, the study took place over 6 months. Do they not report an improvement in their sleep because the improvement happens so subtly that the own person couldn't detect it? Or do we just fully trust that they said, I don't really feel that much better, and so my sleep isn't any better?
So it's a good segue into kind of this whole regulatory landscape. When we prescribe medications, we know how they regulate it, but the food as medicine is a very vague. Now we have the medical foods, which are a bit more FDA regulated. But let's talk a little bit about that, because I think this is one area where I think our listeners would benefit from clarification.
Yeah, this is such an interesting space, and it's blowing up, and a lot of momentum has been gained with like the White House conference on nutrition and hunger. I'm probably messing up that name, but anyways, I'm seeing like a very interesting split, and I think it has to do with the regulatory environment around it. So if you are a food manufacturer or someone who makes ingredients, you have probably, if you're a scientist there, probably studied what you're allowed to say from a regulatory perspective. And the FDA is incredibly clear and precise that food is not a drug. In fact, if you look at warning letters, like take Cheerios, for example, because around 10 or 12 years ago, they said like eating Cheerios 3 times a day could reduce your cholesterol by 4% in 4 weeks, something like that. They got a warning letter from the FDA because, they didn't follow the precise language that you have to. We probably don't have to get into the details, but they said, if you don't change your label, this would be classified as a drug. And, it's not registered as a drug. It hasn't met standards for a drug. So a lot of warning letters that the FDA sends is about misclassification of products and that they would need to be treated as drugs. So anyways, the point I'm trying to make is the food industry has been hit over the head over and over again for a very long time with like, you cannot treat food as drugs. You cannot say that you're going to treat something by having more Cheerios, which has beta-glucan in it and soluble fiber. And I think some academics in the lay public would look at that and say like, well, if I could reduce my cholesterol by having Cheerios, I should stop using Cheerios. I should just say fiber, because the Cheerios is not the important part. If I could just reduce my cholesterol by having more dietary fiber, isn't that a preferable option than having to go through the nightmare of insurance and healthcare to get statins? That seems like it would be a better option. There's another group I work with, or type of organization. Those would be like commodity boards. Think of like American Egg Board, Haas Avocado Board, and those are groups that represent kind of like the whole food. And I think they love the food as medicine part because it fits very well with their own mission and goals of consuming more of these foods, and that they can promote your long-term health. So I find it difficult to navigate how food is medicine, the eventual maybe clash or what sort of gap there's going to be between the two. And if I can give another example, because I do a lot of work in infant formula, everyone agrees, I think there's hardly any debate that baby-fed human milk, whether they were breastfed or mother expressed her milk and bottle-fed them, has better health outcomes than formula-fed babies. And so, I'm not naive about it. The formula manufacturers want to improve their formula so they can make better claims and get people to buy more of it. But the issue gets really tricky when looking at the amazing amount of unique components that are in human milk and what's in formula. And if you're trying to make formula better, it starts to take on this drug-like tone of voice in terms of, we reduced the amount of fussiness and gassiness in these infants, or they have less diaper rashes, or they have XYZ, those things start to sound like the formula is acting like a drug. And that makes it way harder for it to get approved. So you end up in this weird space where you're like, okay, well, we have these things. The science seems really clear that they would be good things, but it's really hard to actually add them to formula and improve it, because then the food is starting to be treated more like a drug. And I'm not at all calling for like more relaxed regulation or anything like that, but I'm curious to just see how the space evolves and see where the dust settles, because I think food as medicine is like antithetical to how the FDA regulates food, and I just wonder how that's going to play out long term.
Let me ask you kind of a follow-up question. I always wonder, Europe seemed to be doing better there. Somehow they have a more intuitive system of regulatory mechanisms. Do you know anything about that? Like why they seem to have less problems and less issues overall, and there's just less of this tension?
I think EFSA, the European Food Safety Authority, does a very good job at publishing. I mean, they have their own journal. It's like EFSA journal, I think. And I think they do a really good job at being very public and transparent around, here are our guidelines, and we have this type of framework to that we're going to judge something by. It's like what I mentioned earlier about sleep and attention. The FDA does not have an equivalent version of that. So you can go on. I wouldn't really recommend anyone go on the EFSA website, because unless you know what you're looking for, it's kind of like a nightmare to look through. But anyways, EFSA's put out this guidance related to how to make a health claim, and they've done it for like, here's what you need to measure if it's immune related, if it's gastrointestinal, if it's brain, XYZ. And I'm looking at them like, wow, this is so amazing. It's just so clear. Like, you don't need to be that much of a regulatory expert to read those and figure out how to design the studies. FDA does not have an equivalent of that. I mean, they do have guidance. They do have like the FDA Red Book and how to measure certain things, but I think it's kind of night and day in terms of the clarity. And I was even paying someone last year to just coach me on like the FDA and US regulatory. And there are elements there where I'm like, man, this really does feel almost like you need a crystal ball, or to be kind of like this mythical expert to figure out what to do, whereas I can just like point and cite published guidance by EFSA. So I think that has a big role to play in that.
Great. Thank you. That makes a lot of sense, because I was always wondering, they just don't have these types of tensions. And here, like Lee and I were trying to pull this study of looking at turmeric for acid reflux, and we run into some conversations. We're like, okay, well, we have no clue how to think of this regulatory question. So makes sense.
Yeah. Well, I think it's funny you ask that, because sometimes people are like, man, EFSA is so strict. Like, they need to get off our backs. It's so much easier to do things in the US. Someone has the complete exact opposite experience. They're like, man, FDA is just like playing hardball. I have no idea what's going on. Europe says this thing is okay or even healthy. Why can't FDA like agree with that? So it just makes it even more complicated probably for consumers to figure out what they're supposed to do when they're seeing like different regulatory differences and cultures and countries and what they're doing.
Agreed. So, when thinking about all of this and nutritional neuroscience, what are you most looking forward to in terms of the research? What do you want to see, or maybe what do you know is coming down the pipeline?
Okay, what I want to see is probably really boring. And I think you'll like it, Lee, because of what you said your husband does with like standards related to the microbiome. And standards development is what I think is the most interesting, because
yes.
Oh man. Okay. So what happens a lot in neuroscience, and not just nutrition related, is someone does like an MRI or functional MRI or something, and they're like, oh, there was more activity in this region. That's a good thing. Or someone goes, oh, there was less activity, but they were just as effective. That means they were more efficient. And you see this everywhere, in the sense of someone goes, hey, this cytokine went up. That's a good thing. Someone says it's a good thing when it goes down. This gut bacteria went up. This one went down. I think we are like lost in the sauce in the sense of what everyone is excellent scientists at like this thing went up or down, but once you get to the discussion section and explaining if that's a good or a bad thing, I feel like we just don't know enough to make some of those assessments. And like a great example is in my PhD, another student was doing research on iron deficiency, and I should pick a different example because the details are slipping my mind already. But anyways, some pathogenic bacteria require iron, and when you raise an animal without iron, you get less of that pathogenic bacteria. That seems like a benefit, right? But we know so much about iron deficiency that it would be wild to claim that people need to be iron deficient because it reduces the pathogenic bacteria. So iron's a great example. It's very well studied. As you mentioned earlier, like there's different types of like restrictive diets. So someone who, if there's not a lot of research in a space and they say, go on this restrictive diet, it's going to lower the pathogenic bacteria. It's very tempting to say that's a good thing. Everyone needs to start going on this diet. They're going to have healthier immune systems. Well, that wasn't the case for iron deficiency. We just might not know enough about a context around whether it's the brain or the gut or immunity around biomarkers and how to treat them. And this makes it really difficult for regulators as well to figure out, is this a good or a bad thing? Cholesterol, great biomarker, pretty clear what that should look like. I mean, I'm sure there's nuance there, but higher is usually not better if you have a healthy levels already. But what does it mean to have a healthy level of a certain gut bacteria? What does it mean to have a certain percent of your brain in your frontal cortex recruited when you're doing a certain type of task? I'm not really sure we know those answers, so I'm really looking forward to kind of just that basic research of developing standards and figuring out what is this outcome supposed to look like? What's the range of normality? And how do we know if things are starting to look abnormal?
So you were right, Stephen. I do think that's neat. And I not only think it's neat, but I agree with it so much to the point that I have a paper in press right now that's pretty much calling for the same thing, but specifically looking around how we study antioxidants in vivo, right? Because if you have an antioxidant and you measure what it does outside of the human being, that's a very different thing than what happens when you put it inside the human being, right? Let's look at vitamin C. Excellent example. Small amounts of vitamin C are going to be antioxidant inside the human body. Large doses, though, we know are pro-oxidant. And so how do you study them in vivo rather than just testing their antioxidant capability outside of the human? Figuring out what is the right question, how should we measure it, and then getting everyone on board to reporting things in the same way.
Yes, that's such a great example. And your last part there of reporting things the same way, some things that get lost in translation between a purist nutritionist and a purist neuroscientist is if a neuroscientist feeds someone fiber, that's how they might report it in a study. We fed people fiber, and a nutritionist is going to look at that and go, excuse me, how much per day and what type of fiber was it? Yeah. And where did you get it from? And you can't just say you got generic fiber from this company,
But yet you will see that in the literature.
Oh yeah, I mean we saw it all the time with pectin. Pectin is like a really common thickener. It's responsible for like the gelling and viscosity in like jellies and jams. So many studies just say we measured pectin, and it turns out that it doesn't gel if it doesn't have a certain level of esterification, and there's just like all sorts of nuance to it. And we were trying to do this review, and we're like, I can hardly say anything about it if all they said was pectin, because there's really different types of it. And I think there's some simple things that could be done to improve some of this. Here's a really simple one. A lot of supplemental material is formatted as PDFs or Word documents, and those are not friendly things for systematic reviewers and meta-analyzers to use. So instead of putting your tables in like formatted Word docs or PDFs, just put it in an Excel document. We were trying to look at like the glycemic index from a recent review on it, and they only have PDF versions, and there's like thousands of rows. Like we just kind of gave up. Like we're not gonna do a bunch of data extraction by hand on that. It would have been trivial if we could just go to like a GitHub or wherever and just download their Excel file and start working with it. And those are super simple things that would go a long way towards like transparency in research and being able to do like secondary analyses of data. And I am continuously surprised by how private people are about the data that they have, like the raw data. Like, well, you published it, just like give a link there, let other people poke around. But as much as like we've made progress in like open science, I think there's a lot of progress to make still.
I couldn't agree more, and that seems like the perfect place to stop. That is all the time we have for today. Stephen, thank you so much for joining us.
Excellent. Thanks for having me.
This is the GW Medicine podcast from the GW Office of Integrative Medicine and Health.
I'm Dr. Lee Frame.
And I'm Dr. Misha Kogan.
Thanks for listening.
The Office of Integrative Medicine and Health produces the GW Integrative Medicine podcast with funds from your donations. Your generosity allows us to raise awareness of the benefits of integrating whole person care, including evidence-based complementary therapies, into healthcare broadly. Help us continue to grow the podcast by making a tax-deductible donation on our website, smhs.gwu.edu/OIMH. Click the Give Now button on the left. While you're there, sign up for our free monthly newsletter for even more evidence-based content, including free webinars.